In this lesson, I'm going to be showing you how you can control particle velocity and direction using the function editor, and we're going to be setting up a time-based function. So we're going to start with an object to emit particles from. We're just going to use something simple, like a sphere, and I'm going to go ahead and just scale it down a little bit. And we're going to go ahead and edit the material and add in ecosystem particles. So now we need to choose an object to use as particle. So we can select the object. And I'm just going to use the sphere object, which comes with the particle library. It's just a basic sphere. That's because we're going to be looking more at the particle motion rather than the rendering of the particles at with this object. So right now we just have a basic particle flow. So we'll go ahead and I do want to note I do have auto keyframing turned off. And that way we can move around the scene a little bit. And I will need to refresh, go into edit the material, and I am going to turn off the fast population mode and recompute. What I'm also going to do is go ahead and select the ground plane and turn on collision. And I'm going to do the same for the emitting object, and so for the sphere as well. We can also switch over to the perspective view and get a little bit of a quicker response. Maybe lift up the object a little bit more and recompute. And I'm also going to go over to the scaling and orientation tab and take the maximum size variation and bring that down to 0.1. And if we go into the general tab for the population, we can double click on the sphere object. And I just want to take a look at the scale of the object for the sphere. And we can cut that down to half, it's 0.5. Recompute. And I just want to take a look and see how many particles we have flowing off the object. So what I want to do is create a little more randomness for the velocity and kind of change the direction based on time. And what I want to use in this case is a technique to sort of make the particles move out in a circular motion. If we were to apply the function we're about to create to, say, an object's position, you would have a very orbital motion on the object. So that's going to cause the particles to shoot off in different directions in sort of a circular pattern, and then we can vary it. So what we need is our time input, and we're going to create a vector by adding in a math node. So we're going to right-click, go to math node, vector operations, and we're going to use the composer 3 in order to create a vector. And if you haven't worked with composers before, the math nodes, it's x, y, and z as numeric inputs. So what we want to do is manipulate time, and what we can do is make it bounce back and forth. So once it reaches 1, we also want it to bounce back in the opposite direction and go down to -1, and then kind of go back and forth that way. And the easy way we can do that is by adding a filter and set that filter to sine wave. Contrast at 2 and brightness at 0 should be good. And what we can do is copy, Control C on the keyboard, Control V on the keyboard to paste. And now we can have one for the X and one for the Y. We're not going to worry about the Z at the moment. What we can do is use another input, possibly the Z input from the normal, to control the Z direction. But for now, let's just take a look at the X and the Y. Now, if we were to keep these equal, what will happen is the motion will just kind of bob back and forth in a diagonal fashion. So what we need is a little bit of an offset. So what we're going to do is add a filter node, and we're going to set it to the offset, x plus a, and the offset of 1, which is the default, should be good. And then what we can do is connect the X input for the composer to the first and the Y to the second. Now, the output of this is going to be 1 at the highest, possibly 2 depending on the contrast, but it may not be high enough to create that much of an effect. So what we can do is also add multipliers afterwards. But first we'll just go ahead and take a look at the velocity. And we can just kind of see the particles rolling off the edges of the object. And what I'm going to do is go ahead and set my preview to smooth shaded so that we can see the full quality of the objects. You can see it a little bit better. So right now, because it's only really going out about 1 meter at the most, you can't see it all that well. So what we're going to do is edit the material, go back into the velocity function, and for the connectors, just before they reach the composer, we're going to add in another filter, and we're going to set it to the multiply, and then we can add another multiplier for the Y input. What we can also do is go ahead and extract both of these and just use the same number to control and increase both the X and the Y. And you do want to make sure that that's after the sine wave, otherwise it will not be an equal motion on each velocity. And the overall output won't look quite as good for this type of effect. So now what I do is I went ahead and increased that. And what we can see is that kind of diagonal motion happening, and that's because it looks like I've got something set wrong just with the brightness and contrast filter. So I'm just going to need to make a change to the velocity. So we'll go into the function, and what we need to do is actually take that offset. Instead of setting it to 1, we need to set it to 0.5. And that way it should correct the motion. And there we go. So now as we're emitting, it is flowing off into kind of a circle here, flowing outward. And it makes an interesting particle effect. There's no Y or Z direction up and down set at the moment. So what we can also do is either manually add in a number to just make it go upward, or what we can do to make it flow off the surface, the normal direction, which is basically the polygon face and which direction it's pointing at. If you haven't worked with normals before, the Z direction would be perpendicular to the face of the polygon. So what I'm going to do is add in another math node. We're going to set it to vector operation and decomposer 3 and connect that to our normal. And now we'll have an XYZ output from the decomposer, and we can connect our composer 3Z input to the Z output of the normal. Now it's still going to be a rather small number, so what we can also do is add a multiply filter to that in order to increase the intensity. And I'll go ahead and set that to 10 as well. So it gives an interesting particle motion. Now there are a couple of different ways we can manipulate and add a little more randomness to this. If you don't want to have just that straight motion going across. And what we can do, one simple way, is to add in a multiply filter before the time input reaches the sine waves and the offset for the y, and use a noise node, just add a noise, and connect it to that multiplier to control it. And if you don't have extract or show parameter connections turned on, which is this button up here at the top, you won't be able to see those connected outputs. So what you can do is extract it if needed, and then change the inputs. I also want to note that I do have automatically map connected parameters turned off. A cool new feature of View 11 is the ability to right-click on these connected parameters and set up auto mapping per node. Whenever you're working with vectors, it's a good idea to have auto mapping turned off. If you're looking for specific values for meters and things like that. So what we could do is either animate this or manipulate it in a couple of different ways. We might need to change the scale, but that should give us an interesting randomization. And right now it's sort of fixed, so what I want to do is go back and set it to animated. That will also connect to the time input. And if it's moving a little too fast, we could also tone it down or increase the scale, modify the scale. And that works a little better on larger surfaces where you have a lot of particles being emitted. We can also change, I'm just going to go ahead and remove that for now, but we can change the speed of the loops and how quickly we move through the entire circle just by multiplying the time input. Another thing that's pretty cool that we can do is set up a noise node on the alpha, animate that, and I'm also going to add a brightness and contrast filter. Turn down the brightness. Black is going to be where the particles are showing, and now the alpha input is only going to work if fast population mode is turned off. Basically, anytime you have connected parameters for emission flow, variable density, scaling, things like that, you do need to make sure that fast population mode is turned off, or they will not show, and they won't have any impact on the particles. So now what's happening is the alpha is moving through the surface, and then particles are only being emitted where the black areas of the alpha are showing. So this is kind of a smaller object, so the noise might not be fully covering it or showing, or the noise may be fully covering it. So what I'm going to do is just size that up. And we might be able to see a little bit better what's kind of going on with the alpha as it kind of flows through the surface, and that might be a little too large. But it gives a very interesting particle flow. You can create some neat emitters this way. And I'm going to go ahead and save this file as velocity functions, so you can load it in if you want. That is included with the training. Another thing is if you do want this to emit from the entire surface, right now it's just emitting from the top, we can turn on the 360-degree population mode. I'm also going to go into the scaling orientation, and we could adjust the direction from surface, whether or not we want it to go perpendicular or vertical to the surface. And we can get an even more interesting flow. And as you decrease the particle size and increase the density, you can get a lot of particles going out there that you could turn metablobs on for and have them merged. And if you haven't worked with that before, you can just go into the ecosystem material, particle motion, and then turn on the render as meta blob. And that will fuse everything together. And if you worked with any other programs that have a similar feature, it's known as metaballs. And the effect can have different names throughout different applications. And now what I've done is loaded in a scene that I've already created where I use the same technique to create just kind of particle strings that flow off in different directions. And it can be pretty neat for creating different water effects. And this one is limited by an alpha that is making sure that the particles only emit in small areas so that there aren't too many particles within the scene. The particles themselves are rather small, so if I was to remove the alpha, there would be a lot of particle generation going on. And I think this is also only a small percentage of the actual particles being emitted. But you can see you can do some pretty cool things with that little function set up with the sine waves. And I've just loaded back in the velocity function scene, and I want to show you, just go back into the velocity, and basically this setup here, what I've done is created a meta node that you can use, and that is included with the training. If I go to my math nodes, meta nodes, and load in circle looper, it's basically this setup. We've got the multiply and the sine waves, and the other multiply with time, and then control for the z. This is just a direct control, so you can set it up any way you like, or you can use this setup that uses the normal input. But it can be very useful for controlling the emissions of particles along velocity, and then you can go ahead and access that from the project content. So it's a nice reusable function, and if you vary it, create some randomness throughout the time, or even within the individual inputs for the x and the y, get some really neat emission flows.